Hello, hello, hello. Hello, everyone. How's it going? Long time no see. Saw you yesterday. Let's wait for a couple of minutes, let other folks join, and then we'll get started. Meanwhile, uh, how's life? Hopefully, you are enjoying GHW that has been happening so far, and you have learned out. Uh, that's too trippy. Should change that. Okay. Yep, I think that's good. So yeah, as I was asking slash saying, that hopefully you all are enjoying GHW so far, and you are learning loads. And what are we going to do today? So I'm going to continue to my third session, which will be like 2 hours long with 10 minutes break in between, and then we'll take a 1 hour break, and then I will be back for my fourth session, fourth and final session for this GHW. So yeah, and what are we going to build? So yesterday, if you were not present, we basically built a text recognizer, okay, a OCR text recognizer. We built a React application. We used things like Tesseract and TensorFlow JS. Uh, and what the user would do is user would upload an image which has some text written on it, and then the app would show what the text is written. And we had like 3 images. From those 3 images, we kind of found that like we built like 3 versions of it. Actually, I can quickly show that. Yep. So we built like 3 versions of the same application. The version 1 was the most basic one, which was using Tesseract JS directly. There was no use of TensorFlow JS as such, and you could upload an image, and it was able to predict one of the things, like one of the images that we uploaded. Not predict, it was able to showcase the text that was written on the first image. That was like really nice. It couldn't do the second and third image. Then we built a V2, which was kind of slight improvement on V1, right? And it could kind of understand the second bit. And let me see if I can run it. I think I should be able to. I didn't make any changes yesterday. So yeah, V1 was okay. V2 was slight improvement, and then we built a V3, which was much better. It could show us the text on the first image and second image properly, but it was very bad at like reading out the text on the third image. Okay, the handwritten text, which had a mix of cursive, capital, small, not really neatly written. Okay, so maybe if I would have listened to my parents and had a better handwriting, probably then it would have been easier for Tesseract and TensorFlow JS to read what was written. Okay, but other than that, that was our day one, like our day one and our 2 sessions. And now we are moving to a different application altogether. And everyone who's joining right now, hello everyone. Hi, how's it going? Yeah, I was just recapping what was like what we did yesterday in the first 2 sessions. And now, as I was saying, we'll go to our third session, and this would be completely different. It has nothing to do with, I mean, it has slightly to do with what we learned yesterday, uh, which is basically TensorFlow JS bits. Other than that, it's completely new. What are we going to do? We are again going to build a project where you can upload an image, but this time we are doing something like an object detection. Okay. Yeah. So we'll do some object detection this time, and we will upload an image, we will use a pre-trained model. Okay, so that's the key today. Yesterday we were not using any model. This time we are going to use a pre-trained model, which is available on TensorFlow, and use that to kind of find what is in an image. Okay, find objects or see which objects can it recognize in an image and with how much accuracy. So we are going to do that. And what else are we going to do? If we have time, I would love to show how can you build your own model. Okay, but that is depending on if we have time, because building your own model would be like very tedious. It is going like not tedious as per se, but more like when you're building your own model, you are writing some code which even some of it is black box even for me. uh, so it's very difficult to explain, and especially if you're not coming from this background, it's going to be more difficult to explain in one session itself. It would require like at least 4 to 5 sessions only to learn, oh, this is what is happening under the scenes. So, and like we only have like legit one session remaining in a way. So let's see, if we have time we'll come back to it. If we don't, then I will kind of give you an overview of what is happening and why. Okay. Okay, moving on. So Replit, my favorite go-to tool. If you have an account on it, well and good. If you don't, I would request you to. And also, before I forget, yesterday I kind of did forget. If you have not already registered, please do register for the session here. Yep, shared the link in the chat. So please do register for the session, because that would help me keep track, help you keep track, help let's keep track. Okay. Link to Replit if someone does not already have an account. If you want to follow along on your local machine, if you have Node.js installed and if you have uh, VS Code or any other editor, well and good. If not, you can create an account on Replit and do it on the cloud platform, which is really nice. So what are we going to do? We are going to create a new REPL. So I'm going to click on new REPL. I'm going to search for React JavaScript. I'm not going to give it this title. The title would be something like GHW uh, object detection. Okay. Yeah, that should be good enough. So GHW object detection is the REPL that I have created, and it opens into index.html. If it doesn't, then just click on index.html and remove this bottom bit. We don't really need it. So this is what we are left with. And oops, my bad. I'm also going to format the documents. So formatting index.html, going over to app.css. Don't really need it. So I will actually delete it this time. Yesterday I didn't, as far as I remember. So I'm going to delete that. App.jsx will no longer import app.css. Let's format this as well. Uh, and actually, let's change the title to object detection. Okay, format this as well. Index.jsx, we're not doing anything, just formatting bits and pieces here and there. And then we will run this. Okay, we'll click on that run button, which is like really highlighted. And what we end up with is on the right hand side, you will see a web view. And there's also an option to open it in a new tab. So please do that. And this is what we see. Very simple, very basic object detection written on the web page. And now I'm going to wait for everyone to at least reach this point on or tell me that there's been no problem as such. If you have any questions, please ask in the chat. I'll wait for like, let's say 10-15 seconds, and then we will get started. Okay. I think this is, yep, all set up. Perfect. Thank you so much. It's all good to go. Let's move ahead. Now, let me get out of your hair. Focus solely on the screen. Uh, can also reduce the size of this. Not really needed there. Uh, can also reduce the size of this. And yep, let me zoom in a bit. So now the screen should be all perfectly aligned for you all. And now let's move ahead. Now, what are we going to do? As I said, we are going to do some object detection. And for that, we are going to use a particular library, which is called as Coco SST, okay? Available under TensorFlow models, last published a year ago, but good enough. I am going to send the link in the chat. So this is the Coco SSD. Like, we are going to download this package, which comes with this model, and we are going to use that directly. Okay, let's go back to our code, and I'm going inside my source folder. I'm going to create a new file. We will call it object detection.jsx. Okay, and if you remember yesterday, uh, we know that the way to create a React component is you do import React from React, and then you can create a function. So const object detection equals to empty arrow curly brackets, and finally export default object detection. And inside this we can create a return which will have a div tag, and inside that it will have a h1 tag of object detection component. Okay, now we can go back to our like, let's format this first. Now we can go back to our app.jsx. Don't really need this h1 tag. We can directly call the object detection file that we created, the component that we created, which will be imported from the same directory, and that's it. Now if we go over to our rendered version, we can now see it's called object detection component, okay, which is coming from here. Very simple, very easy, and nothing, no magic right there. Now we need to install two things. Okay, the first thing that we need to install, which we actually installed even yesterday, was TensorFlow/tfjs. So this one, okay, last published 2 months ago. uh, I don't know why I keep saying that. But okay, so TensorFlow.js, this is something that we installed yesterday. We were, if you remember, we were doing something like import star as tf from TensorFlow/tfjs, right? So yeah, so that's where we remember it from. And let me share it in the chat. And let me silence my phone first. I thought it was already on silent. Okay, so this is the command, and this is the link to the npm. Okay, so okay, coming back, so you go over to the shell, and that is where we are doing the installation. And okay, I have the wrong thing copied. tfjs and npm I at the rate TensorFlow/tfjs. So that's what we are going to run. If you're running it locally, please install it. Same thing that I'm doing. And after that installation gets completed, we will go over to this one, the Coco SSD one. Let me paste that in the chat as well. And let's install that as well. So both of them are installed. You can check your package JSON to see whether they are, which pretty sure they should be. And now going back to the coding aspect. Don't need this AI tab. Okay, perfect. So going back to the coding part of it, now what we are going to do, we are going to write some pieces of code on using this, right? So I am going to start with storing the model. Okay, so let's create some state variables. So const model comma set model, and we are going to use the use state hook that is available. Initial state would be null, so the model is not available. And what else? There's one more thing that we would do is basically upload the image. So if you remember from yesterday, we were doing that yesterday as well, uh, uploading image. So I'm going to create again a state variable image source set image source src. Again, initially this is going to be null. Okay. What else? We are yeah, I think this should be good enough for now. uh, Moving on. Now we also need to import the model, of course. Now if you remember yesterday, we were doing something like the star as tf from tensorflow slash tfjs. That's not really required today because we are not going to use any of the TensorFlow functionalities. Okay, like we are not going to do tf.tensor dot something, which we were doing yesterday. We are only importing this model because Coco SSD model require. We are only importing this library because Coco SSD requires it. Okay, so that is why I am just doing import at the rate TensorFlow slash TFJS to create a context of it, that it exists kind of. And then the thing that we are going to use is Coco SSD. So I'm going to import it from TensorFlow models slash Coco SSD. And yeah, so this is where we are importing our libraries. The first one is TensorFlow TFJS, and that we are importing because Coco SSD model requires it. It requires that it is present, and yeah, that's the sole reason why it is there. And we have also imported the Coco SSD uh, model, and now we are going to use it and we are going to load the model. Okay, so what happens in a React app or a React web app, in the React scenario, when you go over to, let's say, a page and you, let's say, reload the page and your page loads. So that is what you can say is your app mounting or component mounting. So once the component is mounting, what is happening is JavaScript is reading your code line by line, but then it hits the Coco SSD model, and that is going to take time to load. Meanwhile, React is going to skip that loading and move ahead. So we want to create a effect, a use effect, which will say that, hey, whenever you feel like and whenever this loading is complete, please, like, render everything else on the page and wait for this model to load. And whenever something changes, reload this model. Now, in our case, we are going to basically write a use effect. Okay. Uh, it is, as I said, it's kind of, in the React community, they call it as something for side loading, or something that needs to will render, or something that will get loaded later on, even after everything else has been loaded on the page. That is why you have this effect, side effect or use effect hook. So now in this case, we will say that const load model is equal to async, as I said, it's going to take time to load. So asynchronously, this function needs to run, and inside this, I'm going to create another variable const loaded model. Okay, so this is load model, and this is loaded model. That is equal to await coco SSD, the short form that we had written. Dot. It has a load function. Okay, there's no description as such, but ideally this is what helps to load the whole thing. And then you can do something like the set model, which we had created here. So once the model has been loaded, we want to load it to our, we want to give the value to our variable. So that is why we are calling the set model, which to which we will pass the loaded model. Okay, so this is where basically we are storing the model in a variable. It will be available in this model variable. So load model, loaded model. We are setting the model. Now I feel like this spelling is wrong, but I'm going to go with my instinct and say, okay, it is correct. There's too many times I've written model now. So set model to loaded model, and let's call this function outside here. So now we are calling the function. And as I said, you can reload this thing when a variable changes. Okay. But there is nothing, there's no variable which will re-trigger the load of the model. Okay. Once the model has been loaded in the memory, once the model has been loaded and this particular variable here, the model variable here has the value, that's it. Okay, we don't need to reload the model again and again. So that is why I am giving it a empty array of dependencies. So that is basically one way of saying that there is nothing, there's this model loading does not depend on any other variable. So the empty array ensures that this effect will run only once after the initial render, or after the whole page has loaded. The model variable will run only once. Okay. And what else? We can kind of, I think, call it or check if it is being called. I don't think it will have a value yet, but let's see. So if I do that console.log model, clear this and reload this whole page, yeah, null. Yeah, no wonder I was like, what? Yeah, so if you call this model variable outside, once this effect has run and it has set the model, it will be available on this variable here. Okay, model. So if I reload it, initially it is null and then it gets loaded. And once it gets loaded, you can see what's in that variable. It has the model URL where it is coming from. It's coming from Google APIs slash tfjs slash models. So it's a JSON file. Okay. We can kind of copy that, open it in a new tab and check it out. So it's a very big model file. Okay. Really, really, really huge. So that is where the model is coming from. It has some other things. This I'm assuming is when we have to use it for object detection, weight IDs, a bunch of other stuff. But yeah, that is the way, or that is how we have loaded the model. Now we don't really need this console log on line number 16, so I'm going to remove it. So we have now seen what that we are able to actually just load the model. That's the only thing. I was going to go for something big, but then wait, I was like, wait, I didn't do much. all we have seen is loading the model. What else? Now we are going to create a function for handling the image upload. Okay, because remember, all we want to do is upload an image and then do the prediction. So let's do handle. Oh, quick recap again. So yeah, I was saying that all we have done till now is loading the model. We have created this use effect hook, which after the page renders, it will take some time to load. It will like run once, and it will load the model. Once we once the model has kind of loaded, it is available in this variable of model, and that's it. That's the only thing that we have done till now. Now we are going to create a new function called as handle image upload. Okay, remember our discussion was that we are going to create a project where a user will upload an image, and once the user has uploaded an image, the Coco SSD model that we are using from TensorFlow, it will find out which objects exist in that particular model. Could be anything. It could be fruit, it could be vegetables actually, it could be something else. So yeah, we are just basically building a web application which uses this pre-trained model to see how good it is with some images that are downloaded from Google themselves. Okay. Or also you can actually click pictures of things in your house, upload it, and see whether it is able to predict it properly. Okay. So const handle image upload. And inside this, now some of this code is repeated from what we did yesterday. So I'm not going to do console log and show exactly what's coming there. For example, event.target.files of 0, we saw what this was doing. Uh, okay. And if there is a file, so if file exists, in that case, we are going to do something like const reader, and that is equal to new file reader. Okay, so we are creating a file reader to read the file. Then we can do reader dot on load. Okay, in this case, in this function, we are saying that once the file has been loaded or is loading uh, and has been kind of read, and we know it's going to be an image file, so I can do something like const image is equal to new image. Okay, the image dot img.src image source is going to be whatever is the reader dot result. So the source of the image is going to be whatever the file, whatever the file has been uploaded. We could have kind of reduced this code to exactly what it was yesterday, like uh, reading the file, and we already know that it is going to be an image, so we can directly start from here. But this kind of adds some additional functionality slash features to it. Okay, you can also check whether it is an image. Now image dot on load equals to, now when the image has loaded. Yeah, now I feel like I'm doing some unnecessary complexities, but okay, let's move on. Now once that is done, we have a variable of set image source where we can tell it that the image source is going to be img.src, uh, which is here. And the next thing is we are going to create a canvas. If you remember yesterday, uh, when we were uploading our image, the photo which had some text written on it, we were actually showing it to the user once. Then we were doing some grayscale stuff, as in like creating a grayscale of that whole thing. And then we were also showing that on the screen, right? So we are going to create a canvas, and we are actually going to show the image again to the user, the image that the user has uploaded. And we are also going to show another image which the which will have a bounding box. Okay, there's going to be a bounding box which will show what the Coco SSD model has found on the image. Okay, so it will make a box around, like, let's say if there is a full image of a water bottle, and there's a water bottle and there's a keyboard in the image. So I will, like, not I will, we will make Coco SSD draw a box around the bottle and a box around the keyboard, saying that, hey, this looks like a keyboard, hey, this looks like a bottle. Okay, something like that. So we are going to show this image to the user, so that is why I'm going to use canvas. So canvas and set canvas size. Again, a state variable. Now this will have two things. Initially, initial width would be 0, and the initial height would be 0. So on screen, there should be nothing. It should be empty. So use state variable, and you can see, like, instead of having like a single variable there, you can also create an object. Oh, you mean REPL link? Yeah, I'm sorry. I was confused. Like, real link? Which one? Uh, yes, there is the REPL link. Oh, no worries. Cheers. We're going to highlight this. Like, anyone who is a bit behind, you can follow this uh, REPL link to get the code that I have written so far. And we haven't done much yet. All we have done is discussing the project that we are building. The project that we are building is an app where you can upload image, and it will show you uh, what it has detected in the image, and it will also show how uh, with how much accuracy it is, or how much confidence it can say that, oh yeah, this is this particular thing. Okay, so, and the code that we have written so far, it is kind of exactly that. We are building a React application which we will show to the user, which will have a upload button where the user will click on it and they will upload the image. And this function here is for exactly that purpose, handling the image upload and then doing some things on it. The object detection model is Coco SSD that we are using, and this is where we are loading the model, and that's it. That's all we have done so far. Okay, so handle image upload. So set image source, that's done. We will also do the set canvas size. Okay, so set canvas size, it takes in two variables, right? Like, it takes an object. The object has two variables. The first one is width. Now the width would be equal to the image width. Okay, so we are not going to, like, resize the image. Whatever is the size of the image that is being uploaded, we are going to exactly show that. And the height would be image dot height. Okay, so this is the canvas size, image width, image height. So yeah, whatever image we upload, it would be shown in exactly that aspect ratio. Now, after this canvas size is done, which is from here to here, can I take it in one line? uh, It was like very simple and very short. I'm just trying to, yeah, perfect. So set image source, set canvas size. Now, if the model has loaded, okay, if the model has loaded by now, which it should have, but you can never be sure, okay, especially with use effect, you can never be sure. So that is why you should add these things. So we are going to actually create another state variable called as predict. No, predictions. We should create a predictions. So we'll create a function of called as predict. And if the model has loaded, we will call this function. So predict image. Okay, let's create a, yeah, let's create a function later, which we will call predict image, and it will need the img file, the img, the new image that we have created. Okay, so we will call this predict image function to run the object detection. So if the model has loaded, else we can kind of console dot error. Okay, console dot error, model has not loaded yet. So the user can see this particular error and in the console, and they will be like, okay, the model has not loaded yet. Nice. Or we can like also do alert and stuff, but I think this is good enough for now. So if the model has loaded, we will call this function. This function does not exist yet. We have to create it. And that function will take one parameter, which is the image. And then it will do something, which we will see in a bit. If the model has not loaded, if the use effect is going to take time to load, meanwhile, we will get an error in the console saying model has not loaded yet. Perfect. And that is the if condition, the else condition. Uh, the reader.onload. Okay, now this is interesting. So once the reader.onload ends, after this, we would need to kind of, if you remember yesterday, uh, we were converting the image to a base 64 thing, right? That's what we are going to do again today. So read as data URL file, okay? The file that was being loaded, which will be what the user has uploaded. So this is where we are converting it to a base 64 string. And that is our handle image upload function. Now let's write this predict image function. So we can create const predict image equals to, now this would be asynchronous as well. Why is this asynchronous? Well, because the above image upload is asynchronous, because the model loading is going to be asynchronous. So you get the idea, right? So now this will take a variable img, like it will take a value, a prop. Okay, and now even here we will say that if the model has loaded, okay, which we don't really need to, because we are going to call this function only after the model has loaded, but it's good to have some safeguards. Const. Okay, a really good question. What does it mean for a function to be asynchronous? So a synchronous thing, let's first understand what is the meaning of synchronous. A synchronous is that after this first line is done, then the second line will be done, then the third line will be done, then the fourth, then the fifth. So we are going in sync, okay, one by one, line by line. But then there are these few things, example, loading the Coco model. Okay, you saw that when we did a console log, which I can do again quickly. Let me just comment this out, otherwise we'll have error. Uh, you saw that once we do the console.log of this model variable, okay, and reload it, initially the value of the model is null, and then it waits for like there's like a bit of a delay or if I can, let me see if I can go like 3G, okay, and reload this page. Now it should take more time. It should take so much time that we'll be bored out of our minds. But okay, not that much time apparently. Uh, but you get the idea that there was a delay in loading the whole model. Okay, it basically does something in the background which takes more time, and before the model has been loaded, uh, here we actually see the text. Okay, so like let's wait for this is like currently loading. We are loading the whole page on a slow 3G network connection. Yeah, as I said, like we'll be very much bored out of our minds. Too slow. My I should not have done that. But uh, fast 4G, maybe that would be better. Okay, this text is here, but the model, the console.log has not happened yet. Okay, and that will take some more time, and that is why that whole thing is called asynchronous, because once the text has come on the page, the model loading is still happening in the background. And now as you can see it, now we can see the value of that variable, which means that the model has now loaded. So that is what I mean by asynchronous. This thing is not going to happen line by line. And you definitely do not want the user to like have a blank empty screen while the model is being loaded. Okay. So initially we had a blank empty screen because the whole thing was on very slow 3G network. Okay, I changed the network to 3G, but now it's on fast 4G. Uh, but you get the text first and you get the model later, and that is what I mean by asynchronicity, that it's not instant and it's not going to be line by line. You want the user to know that, hey, this thing has loaded and later. Okay, but meanwhile you can show them some text on the screen, so the user does not go like, wait, is this website broken, let me shut this website. Okay, so we don't want that. We want to show something to the user, and meanwhile in the background we want to load the model, and that is what is meant by asynchronous. Okay, now because we are the model loading can happen at a later stage, that is why this function is asynchronous, because well, it depends on the model loading. Also, even the image that you upload, that could be either a 10 KB image or maybe a 10 MB image, and loading different sizes of image will take different times. So even the handle image, let's say, is kind of uh, asynchronous function. Okay, could take more time, could take less time. So that is why we are kind of waiting on the whole thing. Okay, another question on load and on load end. I think yesterday you used on load end. Can you tell me the difference? Okay, let me highlight this question. Also I'll highlight this question. This is done kind of. And this one, the difference I think would be in the name, that the on load event is fired when the transaction kind of completes fully, and the load end is fired when the request has completed, whether successfully or unsuccessfully. Okay, that is what the definition is. So in our case, we kind of using it uh, without the concern of other, maybe like getting idea of what's what are the different functionalities that are available. So I've shared the mdn doc links about them. uh, so when you do the load, you are basically saying that this event has to be successful, but like uploading the image has to be successful. But on when you're using the load end, you can say that, oh, the event has happened, and the request has completed. Maybe the image was not uploaded, but well, who cares? Okay, so the way there is a load end, there's also a load start. Okay, so load, you can think of it as best of both the worlds. And yeah, feel free to go back to the previous one and change it, of course, or uh, change it to using the load, or you can use the load end here. You just need to check what is the what changes need to happen in the API themselves. Okay, so moving on. So if the model has been loaded, good to have safeguards, as I said, even though I don't think it would be it wouldn't be required, but let's see. So const predictions equals to, we will await the model, await model dot model dot, come on. Okay, it's not giving me hints, but there is something called as a dot detect. Okay, and what should it detect? Oh, finally. So dot detect the image to detect objects from. Okay, can be a tensor or a DOM element image, video, or canvas. Okay, so in our case, it is going to be this variable image img. That variable img is basically the file that the user uploads. Okay, predictions, and now this predictions is going to be stored in a variable, in a state variable. We will call it as model predictions. No, enough with the use of predicted value, comma set predicted value. Yeah, which would initially be, since this is going to be just a string, okay, so that is why we are going to set the we are going to set it initially as empty string. So const predictions equals to await model dot detect. So await is basically the keyword to tell our JavaScript that, hey, wait for this output to come back. So once we get the output back, then we are going to call the set predicted value, and we will set the value to this variable that we created, the predictions. Okay, and let me format this again. Nicely formatted. Nice. So we are storing the prediction in the state variable, and this is where we are running the detection. And yeah, that's it. What else? Yeah, we also had to show the bounding box, right? But actually, we can do that in a while. Let's first see what does this whole thing look like. So h1 tag, okay, fine. Let's create an input, which will be type of file, and it will only accept image slash star, so all kinds of images. When there's a on change, okay, whenever user kind of tries to change the image uploaded, it should call this particular function that we created, which was handle image upload, which will, whenever the user changes the image, it should it means that it should rerun the model. Okay, and yeah, that should be it. We will close it, so it's going to be self-closing. Did I click on format? Yes, it's not already formatted. Then let's create another div here. Okay, so there was h1, there was input, now there's another div. What does it look like till now? Let me reload. Also, let me remove this console log from model, and let me increase the speed. 4G, fast 4G is still too slow, so no throttling. Okay, whatever is my Wi-Fi speed is the speed that it should use. And then, okay, we have the button. Nice. Moving on. Now the div tag, this is where we are going to say that we are going to do something called as conditional rendering. So image src, that is our state variable. So we are going to say that image src, if there is a value, the initial value is null. Okay, so null is empty value, but this particular line means that there is a value other than null or undefined. So image src and so if there is a value, then what we need to do is, also let me close this curly bracket. Yeah, so image src and we can create another div here. Inside the div we can kind of write that uploaded image. Okay, a title. So this was the image that was uploaded, is the way of saying this. And we'll use the img, what's it called, like html tag. Yeah, and the source of that image would be equal to the image source variable that we have. We can kind of give it a alt text like upload preview. Not really required, but it's a good thing. And self close it, and let me format it. So div tag with uploaded image, and this is what we are showing the image. And I think that should be good enough for now. After this particular div, the one that started on line 51 and ended on line 58. Okay, now the predictions thing. Okay, the predictions, let me tell you, it's going to be a array. Okay, there will be multiple predictions in an image. So that is why we are going to loop over that array. Okay, there could be one, there could be multiple, but it would be always in an array. So that is why we need to loop over that. So predicted value, no, not predictions, the predicted value. So I think there's a confusion in the name. There would be predicted values and set predicted values. And yeah, I made a mistake. It's not going to be a single string. It's going to be an array. So the initial value, the initial state would be a empty array. So now here on line 43, I should rename it as set predicted values. So predicted values and set predicted values. It's going to be an array. The array would either have one thing predicted or there could be multiple. So right now we are going to go with the most basic, which is like a single, like an array empty, and let's map over it or loop over our predicted values. Keep saying predictions, sorry, predicted values. So we are going to say that if the length of predicted values is more than 0, okay, which means there has been at least one prediction, and let's do some conditional rendering again, inside the curly brackets, of course. So if the predicted values dot length is more than 0, in that case, let's create a div tag and let's write a h3 here saying predictions. Okay, what are our predictions? And now we will loop over our predicted values. So on the top, all we did was check if the length is more than 0, then and only then we will show the below text. Otherwise, we will not. Now we will do a predicted values dot map. Okay, and we will say this will have two variables. Okay, these are new variables that I'm creating. You can call it each prediction comma index. Okay, and this again is going to go over to a p tag where the key would be index. Okay, whenever you're doing a map in React, you should always use a key, but using the index as a key is a bad idea. Normally you should try and use something which is not an index. But in this case, I'm going to ignore the what React tells us, and I'm going to just like use the index. Ideally, you shouldn't. Like, please, if you can, don't. Okay, I think I will style it later. Okay, I will close my p tag here, and inside this, what I'm going to do is I am going to just do something like curly brackets, because not predicted values. This variable that we created, each prediction dot, I think there is something called as a dot score. And yep, so this is the bare minimum, no CSS, very ugly looking image uploading. Okay, but I am going to do one thing. I do need to remove this thing from the stream, because I'm not too sure what will this open. Okay, like if I try and upload an image, so like give me 1 second. uh Upload images. Yep. Okay, so that is good enough. And also let me create a new folder in my replit, where you all can uh basically get these images, right? Images. Okay, perfect. And now I can be back on screen. Perfect. Okay, so on my replit, I have uploaded the images to test folder. There is a basket.png, which is a fruit basket, a bottle.jpg, a classroom1.jpg, .png, which is photo of a classroom, classroom2. There's a single orange, and there's an orange and an apple. Okay, so these are the photos, or these are the objects that we are going to give to our Coco SSD model, which we kind of understand what exactly it is. And we will ask it to predict what it is. So if, and these are the images, or disclaimer, the images belong to their respective owners. I do not own them. These are the things that I downloaded from Google, and anything else that will basically prevent any copyright issues. uh, I don't know, but yeah, not mine. Simple as that. Okay. uh, yeah, so these are the images to test that I have uploaded on my replit. So please download it from there, or you can download your own images, like as in like uh, click your own images, or go on to Google and download some JPEG or PNG files and use that. Okay. Now let's go to, like, I've not made any changes in the code. It is exactly what it was. Let's go to our component, the React TypeScript replit. We'll go on to choose file, and I'm going to give it the bottle.jpg. Upload it. I can see it, and there is a prediction of 0.8842191100120544. Okay, it has predicted something, but we need two things here. This should actually be, it would be nicer if it's kind of a percent. Okay, so 88%, 88.42%, something like that. That would be nicer. And it should also tell us what has it found in the image, because in this case I'm sure it must be the bottle, but in this case of orange and apple, okay, which is 91% orange and 91% apple, which is which, we are not too sure. So we should also ask the Coco model to tell us what is the class, and we should also round off this prediction. Okay, this should be in percentage. So let's do that. Okay, so here in the p tag, okay, right here, I'm going to hit some enter. We will, there is something called as each. So on the each prediction, there exists a dot class, which is basically what it has predicted. So by just adding this thing, if I go over reload, uh, upload this orange too, now you can see Apple. Okay, so the first one was not orange prediction, it was Apple with 0.9169, which is 91% accuracy, and orange with 0.9103, which is like again 91% accuracy. Okay, it has detected these two things. Should also round it off, as I said. So I can do inside this each prediction dot score. Okay, I can wrap it around the math dot round. So around the math class. Okay, so each prediction dot score math dot round, we should multiply it by 100, so then it becomes kind of a percent, right? And then add this percentage symbol. So now if I go over here, upload this orange2.png, nicer, right? Apple with 92% accuracy and orange with 91% accuracy. So 0.9169 became like 92% accuracy, and 0.910 something was 91% accuracy. Okay. Let's try with the bottle again. Bottle with 88% accuracy. Nice. Uh, let's try the classroom1.png. Okay. Chair, 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 chair. Chairs with different accuracies. Okay. Uh, excuse me. Classroom2.png, bigger image. It recognized TV. Where's TV? Oh, is this the TV? Yeah, the TV, the chair, the dining table. Dining table in the classroom? What? Okay, so we really need the bounding box. Okay, then chair, chair, chair. Okay, but for now, I think this was a good enough first iteration. Let me be back on screen. I hope you all reached till this stage. We will now take a break of 10 minutes. And once we come back from the break, we will do a few things. Number one, we'll add some CSS so that it looks nicer. Because along with doing TensorFlow work, we are also doing some CSS work. Okay. A dining classroom. I know, right? uh, so that, then the whole bounding box thing that we talked about, we will do that as well. So we'll write code to show a bounding box uh, around what it has predicted. So then we will know which thing in this whole classroom is a dining table. Okay. Is it because it's of food here? It doesn't look like food, does not look edible. Uh, Okay, yeah, so it will also show us, like by drawing the bounding box, we will know that, okay, this particular thing is what it is calling as the dining table. And yeah, so some CSS, the boxes, and yep, that should be good enough. So if there are no further questions, I think it's time to go on a break. It's 12:04. So 12:14, 12:15 is when we will be back. Lol. Everything because it's a dining classroom. Okay, so let me add the time, save, start scrolling ahead, and yep, we'll be back soon. Okay, just a quick 10-minute break. Yeah, we'll go back to our dining classroom. Hello, good to be back. Let me use the volume. Perfect. Okay, yeah, good to be back. Hopefully, everyone had a nice break. Just had my morning coffee. Uh, Too late for me. And I went around the house searching for something that I can click and try to see if the model can predict it. And what I have found is this. Okay, so I had a potted plant, as you can see, like today, 12:14, like legit 1 minute back. Also, let me remove this banner, which the ticker. Okay, so 1 minute ago, and open. Oops, should have reloaded this. Okay, let's reload. Choose file, plant, upload, and the prediction is potted plant 80% accuracy, which is so cool. I need to be out of the screen for you to see it. Okay, potted plant 80% accuracy. That is so cool. So you can actually give it things uh, which exist in your own house, and it should be able to predict it. Okay, so a potted plant, nice. So the model is nice. It works definitely. And now let's add some uh, CSS to it. That is a beautiful plan. Oh, thank you so much. Thanks to my flatmate. Okay, there's a question. Oh, I sorry, I missed this question. Uh, I would say definitely watch it. If not from the learning perspective, you can kind of build some cool things out of it. Okay, and not every aspect of it needs to be AI ML. Example, if we get around to building our own model, uh, we will use canvas and we will draw on canvas. So maybe even that is something good to learn. Okay, I'm answering this particular question. So like how to build on canvas, okay, how to use React and basically make a drawing board. Okay, something good to learn, something interesting to learn, I would say. So and this is if you don't understand or don't want to do AI ML. But if you want to, then I think it should be helpful. Okay, at least learning about the libraries that exist should be nicer and would help you in the long run of things. Like the way the AI is growing, it's good to have some knowledge about, oh, these are the newer things that you could use to build out stuff. Okay, if you it's okay if you don't know the math, uh, but I think it would be nicer to at least know what libraries you could use for day-to-day work. Yeah. uh yep, so let's go back. Let's do some styling. Okay, this time I am going to create a separate CSS file. Okay, so let's call it object detection dot css, and all the CSS that we write will be in, not all, but let's try and add most of our CSS in this file. So we will create a class called object detection, and here we will go like the text align should be center. Let's add some margin of like 20 pixels or something. Let's add some padding, dash bottom of like 40 pixels. Yep, perfect. So this should be good enough. Then the dot, what else? So let's try and use it first. Let's remove this one. So the object detection, this will be the wrapper around this thing. So class name equals to object detection. Also, we need to import the CSS. So we can just do like import dot slash object detection dot css. Okay, so that should be good enough. And if I open it again, yeah, things are center aligned. Nice, which is good, right? Okay, so what else? So that is one thing where we are using the CSS. We can also in our div of images, image source. Yeah, here we can create a class name of images dash container. Okay, let's take this particular class name and add styles to it. So images container, it will be display flex. Okay, justify content to be center. Gap between two things would be around like 20 pixels. And from margin dash top, 20 pixels. Okay, and what does this do is if we go over, take our bottle.jpg, upload, there's some spacing around. Okay, perfect. More center aligned, spacing up and down, so there's kind of a scroll, and now I don't have to like minimize my screen and stuff. What else? This particular div, let's give it a class name of image dash wrapper. And can just do like text align to be center. What else? This particular img, okay, the where alt tag is upload preview, let's give that a class name as well. We can call it uploaded dash image. You can go like uploaded image. What can we do? So let's give it a max width of 100%. So should stay kind of inside the screen. The height to be auto. Let's give it a border of 1 pixel, solid, and hash what, red, red, dark red, Indian red, orange red, medium violet red. Don't know what that would be. Uh oh, this doesn't show it. One place that I really like to go for colors is Tailwind CSS. If you go there, you search for customizing colors. As you can see, I've searched it so many times. I think this palette is like good enough. So since this is going to be a border, I am going to go with this particular color. And yep, that should be good enough. And you can add a box shadow so that the image looks like it's floating. So 0, 0, 10 pixels. Yeah, and the RGBA color would be like black, but with like just 1% opacity. Oh, sorry, 10% opacity. So now if I reload this thing and let's say upload a plant.jpg, yeah, you can increase the border here. I think 1 pixel is too light. Yep. And the border color, I'm going to go with white. props. Okay, so yeah, kind of getting it in the center. And there's suggestion about changing the font and underline the object detection and change the font. Okay, so like this p tag, we can, yeah, of course, add a class name to that as well. Uh, or you can also do inline styling if you want. Okay, so like let's say I am going to say the margin around that should be like 20 pixel or 2. Not really required actually. Let's just do the font size. Font size to be like 2 rem or something. Choose a file. This one. Yep, big enough to look at and understand. Uh, yeah. And let me look at one thing. I'm not too sure what's. I upload this one. I think the font is Times New Roman. Oh, Times. Family name is Times. Times Bold. Okay. Uh, hmm. Could change it to Arial or something. So like font family could be monospace, sans serif, serif. Let's say if I do monospace, how does that look out? Bottle 88%. Okay, could go with that. Okay, and we can change the font family for everything else to be, let's see what are the options available. But it doesn't show. I think Arial should be Arial, and don't really need this, I feel. Semicolon. Yep, there we go. Arial. Okay, so that's some styling. Uh, like very basic, just so that it's easily readable. But we also need the other bounding box, right? The one where we can kind of see exactly uh, what is being selected and what is being highlighted. Uh, okay, so let's do that. So what are we going to do? We would need to create a new function. Okay, so let's go to our code, go to object detection and canvas size. Are we not using it? I don't think so yet. Yep. So handle image upload is done. Let me format this whole file once. Uh, yeah, after the predict image, let's do the drawing of the bounding box. So I'm going to call it draw predictions. Okay. And that is going to take two things. It's going to take the context and it is going to take not CSS maths, context and predictions. Okay, these are the two variables or the two values that it will take. And we will say that predictions is going to be, so this particular predictions is different from everything else. So we can call it like predictions, like, okay, let's keep it predictions only because that makes sense. So that is going to be an array. So for each of those predictions, okay, prediction, what are we going to do? So we are going, like, this function draw predictions is basically the one that we will call to create a bounding box around what has been selected or what is being predicted, what part of the image is our model actually looking at to understand. So that is why, and since there are going to be multiple predictions, as we saw in case of that apple and orange, uh, there could be like two of them. So that is why we would need, so it's going to be an array. So we will need to kind of loop over it. Okay. So predictions dot for each individual prediction. Okay. That's a new variable that we are creating. We will need to destructure some stuff. So prediction dot b box, okay, that is bounding box coordinates. Okay, so dot b box is bounding box coordinates. From, so from this particular variable we are going to destructure the x, the y, the width, and the height. These are the four things that we are going to destructure. uh, can I use it somewhere where you can actually see it first? Let's see. In this image source image container, once you have the image wrapper, this is where it ends. I think right after this. Yeah, here. Image src and we can have another uh, div with the class name of image wrapper. So exactly this particular thing. So I'm going to try and show you a empty canvas, actually, kind of. So h3 of predicted image, format this. And then after that, we can do canvas with the width equal to you remember the canvas size variable which we were not using. So width of the canvas would be equal to the canvas dot width. The height of the canvas would be equal to canvas size dot height. And we can give it a class name of predicted dash canvas. And I think we could close it here. Yep, let me format this. So width, height, and class name. So if I go over to this replet and give it, let's say, this particular image. Okay, so we can see the bounding, like we can see something there that it's coming. There's nothing much there. So let's try and let's try and call that function that we are writing. So canvas ref. Okay, in this case, we can go like if canvas ref and uh, the predicted values. That's what it was called, right? Predicted values dot length greater than 0. So if that is the case, then call this particular function the draw predictions function, and it will take the context. Okay, it needs the context, the ctx, and it also needs the predictions, which in this case would be the predicted values. Now where is the ctx coming from? We will need to create that. So const ctx equals to canvas ref dot get context of a 2D. Okay, why did I go through all of this? To show you what comes in the bounding box. Like I want to plot these variables and see if I'm able to plot it before I complete the whole code. Also, a quick trick if you don't know already, if you don't want to do what I was doing since yesterday, uh, like adding a string here, comma, and then like a colon and something, you could kind of wrap your variables in uh, curly brackets, which makes it an object. So it will now become a key value pair. Okay, so now if I reload, open my console, try and upload the image, as you can see, there is now this is the value of the x, the x coordinate, the y coordinate, the width, and the height. Okay, so this is the size of the bounding box that should be made around this image, is what these variables mean. So you can also kind of plot the predictions. What is this? Yeah, prediction.b box. Reload. uh take this image again, and now this is what, like, uh you can see the prediction.b box 105 is basically the x coordinate, so how much ahead in the x coordinate, and then how much on the top on the y coordinate, y axis, what is the width going to be, and what is the height of the box going to be. Kind of that is what is coming from that prediction.b box. Okay, so just to show that, I had to write this piece of code of calling the canvas and stuff. Okay, we will make some changes here. We'll get to it. uh, this is where we are saying that if the canvas exists, then do some stuff. This is where we are creating a 2D context, or the 2D image. Like if you remember from our yesterday's discussion, you could do something like web GPU, web GL, where you create 3D objects, but in this case it would be 2D. And this is the function that we have created. Okay, so that's all that we have done. This CTX, need to use it. I'm now going to remove the console log, and let's get ahead. So now, what is that context, the CTX, going to do? So we can kind of give it some attributes. Like example, set the color of the box to be like red. So it would be like the stroke style would be red. Okay, you can also set the width of that line. So dot ctx dot line width is, let's say, 4. Okay, what else? So this is the width of the bounding box. There is going to be a box around the bottle. Now what should be the width and the height and the color? That is what we are kind of uh, writing here. Okay, you can then tell it what should be the shape of that bounding box. Well, is supposed to be a rectangle. Okay, you can, this could be a circle as well actually if you want, but in this case I am going to keep it as the stroke to be rectangle. And to make a rectangle, you need uh, the x coordinate, the y coordinate, the width, like how wide is it going to be, the height, how high is it going to be, right? Perfect. You could also set the font style, font color, a bunch of other stuff. So example, uh, okay, we can do that later. Plus, what should the bounding box show? So like right now, if I go with just this much, okay, so I'm not doing anything else. This is the smallest ever, I think. uh, Okay, not smallest ever, but ignore me. So this is going to make the bounding box, but we are not going to add any data or write any text on it. But we do need to go back to our canvas part, which we had written on line 75 to line 85. Inside the ref, if there is this, okay, if this exists and there are values in that prediction, we are creating a context. Then we also need to show the image, right? So const img, so this is a new variable, uh, and we are initializing or creating a new image object. Now this img which exists here, img.src equals to image src. This image src is the one that is in the useState variable. So the canvas that is being created, okay, the image inside that canvas will exactly be what was uploaded by the user, and that is what this base line basically means. And now when the image has been loaded, so img dot on, let me actually kind of give it a different name for you to understand. This is canvas img. Okay, so canvas img dot source and canvas img dot on load. What is going to happen is that step one, it should first clear anything that exists on the canvas from before. So it should basically clear the rectangle. So 0 comma 0 comma canvas comma width, canvas ref I think would be, yeah, that's what we have, right? Canvas ref dot width comma canvas ref dot height. Okay, so we are clearing anything that exists from any previous image that was loaded. Then we are going to draw the image. So draw image, ctx dot draw image. What are we going to draw the image on? This variable, this canvas image variable. Okay, and what are we going to draw on it? The values that come from the predicted values. Oh no, sorry, wrong. Canvas image and 0 comma 0, that is the dx and dy, like smallest parts of it. You can check up what would this do, and I need to take actually this thing just above here. Yep, that should be good enough. Let me reload, and now let's upload the image of one bottle. And as you can see, it creates this bounding box around the bottle. Perfect. What about the plant? So where's my original plant? Where did my original plant go? But it chose this whole thing as the plant. Oh, I created a new CSS, right? But I forgot to use it. And let's try the classroom too. So there's one thing here, this thing, and this thing. So the red boxes that you see is what it is checking. This is the TV. And then pretty sure this is the chair, this is the chair, this is the chair, and this thing is the dining table. Okay, is what Coco SSD thinks. And then chair and chair. So 1 2 3 4 chairs. So 1 box for chair, 2 box for chair, 3 box for chair, 4 box for chair, 1 box for the dining table, okay, which is this one, and 1 box for TV. So we can also write on top of, like on the top of this bounding box, what is this? Okay, so we can write this class name, okay, the class on top of this. So let's do that. But meanwhile, let me take this predicted canvas and go to our this thing and comma dot predicted canvas. Perfect. Oof. Yeah. So now if I take my plant, upload, yes, side by side, looks much better, right? Potted plant, this is the box, and perfect. Okay, now, okay, let's write some text. As I said, let's write some text on the box itself saying that, hey, this is what I think it is. So we can use like ctx dot font, okay, and we can set the size of the font, let's say 24 pixels, and Arial, uh, that's the font size and the font style. We can give it a color, and I think the font color comes from fill style. Okay, let's say it is orange. Yeah. And then what should be the text? So ctx dot fill text. Okay, now this is going to be interesting. This is going to be something big, so it needs this, it has to have the string and stuff. And then you define the x and y coordinates, like where should this be based. So let's try and add that. So step one, you see this prediction. When we were doing like mapping over the predicted values, we were calling it each prediction, and there was each prediction dot class. That is that predicted values is the same thing as predictions here, and now we are calling it prediction, just prediction. So it should still have the prediction dot class, or if not even that, let's see what it contains actually. So we can do console dot log, and let's plot what is in the prediction, each prediction. Okay, what's the data in each prediction? So that ways you get a better understanding of what's coming. So reloading it, going to upload my potted plant. So what does prediction contain? It contains the b box, which we know it's x, y, width and height. Then it contains the score, which is basically what we are converting to percentage, and it contains the class, the potted plant. Okay, so that is what we are going to use. So I am going to do like ctx dot fill text, and this inside. Now I'm going to use template literals, or backticks as it is called. And this would be first the prediction, which is this particular variable, dot class. And we are going to do exactly the same thing that we did here, the math dot round thing, so that we can see it in the same line. So I'm going to copy that. I'm going to come up to this fill text and paste it here. Needs to have the dollar symbol so that it understands that, hey, this is a variable, and this each prediction should be changed with the variable name that is given here, which is prediction. So prediction dot class, prediction dot score. Perfect. As you saw, fill text also needs the x and y coordinates, uh, as in like where to plot it. So I will say it should plot it on x and should plot it on y. Okay, I feel that should be okay. I'm going to format it. Let's come back and let's upload the bottle.png, and bottle 88%. This is where it is, writing it. So now let's go over everything. Okay, there's one, I would say, slight problem. It is written here, but it's the orange color. It's too bad, I think. Red, would that look better? Yeah, I think it's like, it looks much better, I feel. And the y-axis, it kind of merges in the y, right? So I mean, that's something that you can kind of look at, how to improve that. Or I think what you could do is, if y is greater than 10, then y minus 5 or 10, I think that should kind of format it to be slightly above. Yep. Uh, for the basket, let's see. Dining table. So it did not recognize any fruit in the whole of the basket. All it recognized was dining table with 54% accuracy. Okay, what else? We know about the bottle. It's been done long enough. Classroom. So it recognized the chairs. So this chair, 79% accuracy. And then this particular chair here, then it recognized a chair here somewhere. I think the bounding box could be wrong. And a chair here. Okay, so it recognized like 4 chairs. Oh, I don't think the bounding box is wrong. It's what the Coco SSD saw. Then we saw for this one, okay, so TV, and this is the dining table. Yep, this whole thing dining table with 81% accuracy. Chair, 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 and chair. Uh, Classroom 2 is done. Orange 1 dot this 98% accuracy that this is definitely an orange. Okay, nice. That was a good one. And for the last one, orange and apple. Okay, so orange with 91% and apple with 92%. Perfect. So yeah, that is actually all of uh, this session. What we have done, we have learned how to use a pre-trained model. Okay, and the model that we used was Coco SSD. Pretty sure there must be more. So if I just search for this at the rate TensorFlow models, hit enter and hope for the best, because sometimes it searches, sometimes it doesn't. I'm going to go over to npm website, click on this and click on the search. So there are a few more TensorFlow models. There's one for pose detection. There's KNN classifier. Coco SSD is the one we use. Body segmentation, mobile net, hand pose, face detection, uh, universal sentence encoder, Q&A, question and answer model. Uh, yeah, these are all the TensorFlow models that are available. Okay. And I think this is the only one for object detection. But there are a lot for hand and face detection, which brings me to this question. Can we use camera instead of image? Yes, we can. Yes, you can actually use the camera instead of image. So all you need to do is write the camera web, use the camera web API, which let me see if I can find. Yep, found it. Can share it in the chat. So you can use this API kind of to basically get with the user's permissions through a prompt, turns on the camera and or microphone. Okay, so you can kind of use that. You can learn more about how to use it and stuff. What happens, what does it return, but basically switch the camera on, and then you can change the code in a way so that when it's basically waiting for the file reader, instead it should uh, take the whole image, no, the video feed, and give it to the predict image. And we know that the model dot detect, uh, if it allows me to, apparently not, but if you remember, I think there was one time where it was showing that it takes in that whole yeah. Yeah, right here. The image to detect objects from can be a tensor or a DOM element, image, video, or canvas. Okay, so you can pass the whole video to the model and to the model dot detect, and it will detect it. Okay, so yeah, you could do that as well. And that kind of brings us to the end of this session. If you can, like, other than TensorFlow JS, if you find more object detection models, uh, that like pre-trained object detection models, definitely give it a try. I remember on TensorFlow website, TFJS, there was a models, right? TFJS models. And is there any for object detection? Only Coco SSD, unfortunately. But any other would also be nice. If not TensorFlow, anything else. Like Look at this. So cool. Okay. So, yeah, that brings us to the end of this session. If there are no further questions, or if you have any, please ask it in the chat. Or if there's no further questions, I will see you all after an hour. Okay. And in that, I'm pretty sure I won't be able to complete the whole session if I do like line by line coding. So I will write some pre-code. Okay, I'll write some basics, and maybe we will go over that again. Okay, uh, code for canvas ref would be this one. Oh, the canvas ref. Sorry, my bad. Here, uh, the whole code should be available here. So if you go over to this link, I'm not going to delete it. Uh, you can find it right here. Okay, so that's everything, I guess. Uh, yeah, I was saying that I will have some pre-written code so that we can just go over it line by line, and then you all can like we'll do some understanding bits, and then we will do the model training bit. Okay, not too sure if it will run on Replit actually. So even that is something that I'll need to try out quickly before the next session starts. But other than that, yeah, I think it should be fun. Training our own model should be fun. Okay, cool. Thank you so much, everyone, for joining. And have a quick lunch, breakfast, dinner, and I'll see you back after an hour for the fourth and the final session of machine learning and JavaScript. Hope you are enjoying everything that's been happening so far. Hopefully, it's not too slow, it's not too fast, or I'm like it's making sense. Okay, cool. Thank you so much once again, everyone. Cheers. See you. Bye.